Okay, guys, we are now beginning Unit 13, where we're going to briefly talk about indirect proofs. This is the last section that we have on proofs, so I want you to read Chapter 5, pages 126 through 131, and you're going to learn this last procedure for doing proofs and proven validity via proofs, okay? And so technically it's not a rule. It's not a logical rule. It's a method for proven validity that's been developed. And so so it's important to learn it that the basic idea is, if you assume the conclusion is false and it produces a contradiction, then the argument is valid, because if an argument is valid, if all the premises are true, then the conclusion must be true. So that therefore the conclusion, if the conclusion is given as true, then all the premises must be true. They couldn't contain a contradiction. And so you'll see them explaining that in more detailed in this section. And so they talk about, a contradiction or a contradictory sentence is any sentence that is logically inconsistent, any sentence that cannot possibly be true, which means it's always false. It's necessarily false. And so some contradictions are more obvious than others. An explicit contradiction is a sentence of the form P and not P. That's a very explicit contradiction. So obviously such sentences cannot possibly be true, and that's what you're trying to generate in a indirect proof. And so they are necessarily false, an explicit contradiction. Yeah, so logic alone guarantees the falsity of contradictions. So given the definition of a valid argument, a false sentence cannot be validly inferred from true premises. Okay? So if we infer validity to a contradiction, we have shown without question that at least one of our premises must be false. And that's what an indirect proof does, and then the method of doing it. So they say, now consider we have a four premise argument and assume we know three of its four premises are true. If we derive a contradiction from that set of four premises, we have proved the fourth premise in the set is false. At least one member of the set is false, and we assume that the other three are true. So we've also proved that the negation of the fourth premise is true, since the negation of the false sentence is true. And we have here the main ideas behind what's called an indirect proof, also known as reductio ad absurdum proofs, because an indirect proof, an assumption, is reduced to absurdity by showing that it implies a contradiction. And so they say, take the argument A horseshoe B and B horseshoe C in A, and then therefore C. So they say, let's add the negation of the conclusion. This is what you do in an indirect proof. You add the negation of the conclusion. That's the assumption in this. So you're assuming this. Like a conditional proof, you have an assumption in this type of proof as well, and it is the negation of the conclusion. And so, namely, negative C, you add that to the set of premises to obtain the following argument. So you have, as you see there, they add, A, you have 1, which is A horseshoe B, 2, which is B horseshoe C, and 3, which is A. Then your assumption is going to be not C. And by doing that, you see that they obtain a contradiction by doing a regular, method and form of proofs on that. It implies a contradiction, yet you can derive A and not A. And so they say, obviously, if premises 1, 2, and 3 are true, then the added premise 4, not C, is false. And if not C is false, then C must be true. Using our new rule of indirect proof, we can now discharge not C, having shown that the assumption implies a contradiction, and place it as our conclusion, C, on a new line via indirect proof. And so to sum that up, by assuming not C, by assuming the negation of the conclusion as a premise, then deriving a contradiction, we've shown that the argument that they gave there, this is all on page 126, is valid because we've shown that if its premises are true, then its conclusion C must be true, because not C must be false because it implies a contradiction. You were able to derive a contradiction from it, from just those premises and that assumption. And so that's what a indirect proof seeks to do, to reduce the argument to absurdity, showing that the negation of the conclusion as a premise results in a contradiction. So therefore, the conclusion, the negation of the conclusion is false, which means the opposite is true, which is to say the conclusion is true. And so if it's true, then you've shown that it's valid. So the method for doing this is how we explain. So an example is on page 127. So on page 127 we have an example there. And so they have premise 1 is not A. Premise 2 is C or B. Premise 3 is C, horseshoe, A, V, B. Your conclusion is B. So in indirect proof, you use brackets again to bracket off the assumption, and the assumption is not B. Okay, and you write assume next to that, and what your goal, your first step of goal is to generate a contradiction from not B, and you start figuring out a way to do that. It doesn't have to be involve the letter B. The contradiction does not have to involve the letter B. It just needs to generate the letter B generate the contradiction given the premises that are there and it being not B. So you take that not B and you start thinking of ways of maybe producing a contradiction. So is the first move they make. They do 2 and 4 disjunctive syllogism of 2 and 4, and that gives you not C. And then that gives you C. And using that C right there, that'll give you AVB, modus ponens of 3 and 5. And now that you have that, you could apply the number 4 to 6 for disjunctive syllogism and give you A. And now look at here. You have not A here, it's one of your premises, and A here. So you can join them. And that gives you the contradiction, and you close that out, and you've proven the indirect proof of 4 through 8, indirect proof. And so that's kind of your steps in doing that is you negate the conclusion as an assumption. You bracket off, and then you close it off once you have generated that contradiction there. Okay? Then you close it off and you notate it that you have derived the contradiction via indirect proof, and therefore shown that this argument is valid. You've shown that it is valid. So I want you to keep working these examples on this indirect proofs. Your homework assignment for this week is due 5-3, numbers 1 through 5. And like I've always said before, you're free to do, and I would encourage you to do some of these examples that are not assigned, and do the ones that have the answers in the back so that you can practice. So practice makes perfect with this stuff. And then for next unit, we're going to have some fun, and you're going to get to read about modal logic, and you'll be introduced to this idea of modal logic, which had a kind of a renaissance and resurgence in philosophy and analytic theology and some systematic theology, and so I want you to read for next time. Read chapter 15, and I have a couple pages there, pages 109 through 309 through 315, and 322 through 325, and we're going to talk about some ways in which modal logic's been applied in apologetics, in areas of God's, some theological areas about God's nature, and have some fun with that, and then talk about assignment that's due. It's a little different for the last unit. So, like always, if you have any questions about anything, get in contact with me, and I'll be grading your homework and giving you feedback on that. So be looking for that, and hope you have a wonderful day.